So for today, I started with talking about the Fibonacci, which is a pretty cool sequence we find in nature, but not one we're probably going to test you on. This is just, there's a lot of different ways to find sequences that are unusual. And this teacher started with these. I'm going to frankly not try to go over all these unusual kind of sequences you can do. Let's go to the more mathy ones. So let's say you had that. What on earth does that mean? All right. So a sub n, I'm reading right here, is called the nth term of the sequence. And this is how they write those sequences when you're in higher level math. So this is like any random term in the sequence, and you go from 1 to infinity to keep writing that sequence. Okay, I'll give you a really simple one. Say I said 2x, and then I said from zero to 5. What that would mean is, where do you think I'm going to put the 0? In the x. So it'd be 2x, but the x is 0, so it'd be 2 times 0, so it would be 0. To get the next term, I take my 2x, and I'm going to put in 1. And you just keep using integers all the way between 0 and 5. So if I put in a 1, it's 2 times 1, so it's 2. You see how that's being generated? 2x is kind of my term generator. And I keep sticking in numbers. So if I take 2x and I stick in 2, it'll be 2 times 2, and then it'll be 4. So look at this, 0, 2, 4, and you might be like, why don't you just say we're just going to keep adding 2 each time? Yeah, that's what's happening. But there's this way of writing it that you kind of got to get used to, which is that you have your equation, and you start with 0, and you keep going until you put in up to 5. So I'm just going to finish this off and do it pretty quickly. This was putting in 2. This is putting in 3. 3 times 2 is 6. This is putting in 4. And 4 times 2 is 8. And this is putting in 5. And 5 times 2 is 10. So there's my sequence. 0, 2, 4, 6, 8, 10. The nice part is it tells me where to start and where to end. Okay, so this is totally different than what you learned in higher algebra. Those were recursive sequences that were written with like u sub n and u sub n minus 1, and we don't do that for higher level sequences. All right, so what if the sequence was this? Well, let's look at this first. What's the first thing that n could be? 1. Stick in 1, everybody, and figure out what you get. It's 3 to the 1, and that's 5 to the 1 minus 1. Soren, what'd you get? 1/3. Okay, now let's put in 2. Because look, it just says keep going, bigger than 1, right? And just to clarify, you don't ever use like 1.2. You always use integers. So something bigger than 1, so we're putting in 2. Everybody put in 2. 5 to the 2 minus 1, which is 5 to the 1, which is 5. Over 3 squared, which is 9. Who had 5/9? Okay, good. Pausing the video for a second. Okay, so now everybody put in, well, you're going to keep doing this forever? No, but we want to see if we can figure out a pattern. And from only 2 numbers, you really don't see the pattern super well. So would you please find the next 2? 3 to the 4th is one of those ones that seems really hard to memorize, but if you write it out, you go, oh, it's 9 times 9. 3 to the 4th isn't that bad. Okay. So you getting the pattern here? All right. So that's one way to write a sequence. Here's another way. Do you get what they mean by here, by this? Well, you'll really get it a lot better if you write out the first 3 terms of it. So to get the first term, Henry, what should I do? Yeah, plug in n equals 1. So I'm doing this in my head. 2 times 1 is 2 minus 1 is 1, comma. Now we're going to stick in 2 because we're going to keep going until we hit infinity. So obviously we're not going to go forever, but I find the first 3 terms usually enough to kind of tell you what's going on. Okay, so if I put in 2, I got 2 times 2 is 4 minus 1 is 3. And then I put in 3. 3 times 2 is 6 minus 1 is 5. Okay, I'm catching on to the pattern. 1, 3, 5. Do you get what's going on? Okay. So dot, dot, dot. It's always good to show that this doesn't just stop. 1, 3, and 5 aren't it. That's just the beginning, and then it would keep going. All right. And this is another way to write a sequence. A sub 1 is 7. A sub n plus 1 equals 2 minus a sub n, where n is greater than or equal to 1. That looks a little bit like that thing you did in higher algebra, recursive. They're saying the first term is 7. Now stick in, obviously, n is greater than or equal to 1, so stick in 1 and see what you get. That'd be a sub 1 plus 1 is 2 is equal to 2 minus, well, what the heck is a sub n? It's the term before it, yes. If we're doing a sub 2 right now, a sub n, wait a minute, n plus 1. Yep. So then 2 minus 7, and what's 2 minus 7? Negative 5? How many of you got negative 5? Okay. I think I'm doing it right. That's kind of a weird one. We don't use that one very often. The point, there's a lot of different ways to describe sequences. Like you can say these a million different ways. And you have to be able to handle it when we throw you a weird way on a test or on homework. All right. Arithmetic are the kind where you just add something each time. What's being added each time here? Don't overthink this. What's being added each time? Okay, 4. That's one of the most common kind where you just add one thing over and over again. Now, wasn't this one of the previous ones? Yeah, some of those previous ones were just adding 4 each time, but they wrote them in this strange way, but they were still arithmetic. In the end, each term was just going up by a single number every time. But some of them weren't that simple. All right. This is an important formula. Now, I know you've got it written on your notes, on your slide. So to be able to figure this out, we need to use it. So let's do an arithmetic sequence. We'll start with a really easy one. We'll start with 2, and then we're going to add 5 is 7, and we're going to add 5 is 12, and we're going to add 5 is 17, dot, dot, dot. We're just adding 5 each time, get it? This is the formula you'd use to figure out the 10th term without having to do it the caveman way of just adding 5, adding 5, adding 5, and doing it forever, okay? See if you can figure that out. I want to know what's the 10th term. That is a sub 10. Figure out a sub 10. Pause for a second. I bet you can figure out n, and I bet you can figure out d. Hint, it stands for difference. Okay, Jack, would you walk me through this? I want to find a sub 10. What do I do?
Oh, I'm not quite sure, but I just
I'm going to give you a hint. A is the first term. So 2. Plus n minus 1. From this right here, you should be able to tell me what n is. If a sub n is a sub 10, what's n? You're overthinking it. A sub n is a sub 10. What's n gotta be? A sub n is a sub 10. N is 10. That's all they're saying. They're just saying that the little subscript number there, that's n. All right, so in this case, we're trying to find the 10th term. So then n is 10. Minus 1, oops, times d, the common difference. How much were we adding each time?
5.
There we go. It's a 2, but then 9 times, see the 10 minus 1 is 9? We added 5. We added 9, 5, no, we added 5 9 times. We add that 5 9 times. To get the 10th term, you have to add it 9 times? Yeah, because your first term was this one. To get the second term, you'd add it only once. To get the third term, you'd add it twice. You getting how it's always one behind? To get the fourth term, you only added stuff 3 times. That's why it's always one behind. I was trying to explain why the formula is this way, but in the end, we know it works. 2 plus 9 times 5 is 45, 47. What did I just figure out? What is 47? It's the what? 10th term. Make sense? All right, now, having given you this formula, I should be able to just say 1 plus 3 is 4, plus 3 is 7, dot, dot, dot. What's the 10th term? Use that formula I just taught you. Figure out the 10th term. Pausing. Okay, so a sub 10, n is 10, remember? The subscript is this. This is the little subscript. And a is the first term, which was 1, plus, oh, wait a minute, I'm starting to get this. If I want the 10th term, I'm going to have to add 9, that was the 10 minus the 1, sets of whatever I add each time. In this case, it's 3. 9 little adds of 9. Or sorry, 9 little adds of 3. So, bottom line, 28 would be the 10th term. Raise your hand if you had 28. Okay, cool. I think you get that one. That's one of many little formulas that you're going to have to know for this next test. All right. Moving on. Are we adding something each time here? Well, yeah, but are we adding the same thing each time here? No. So then this isn't arithmetic. This is the other kind. What's the other kind? Remember the name? Geometric is correct. Do they have to get bigger each time? No. Look at this one. It got 1/10 as big. This one 1/10 as big as that. So it's timesing by 1/10. So if I want to make something bigger, I times it by something bigger than 1. If I want to make something smaller, I times by something smaller than 1. So like a half. Cut it in half each time. All right. So how are they similar or different? Well, it's the same thing each time, but it is multiplying or multiplying. It's always multiplying, by the way. Never say dividing. It's weird, but we never divide in sequences. We always multiply by a fraction. Okay, so like this one was clearly going down, but if I take that divided by that, 3 divided by 9 over 2, that's like 3 times 2 over 9. That's 6/9, aka 2/3. That's what we're multiplying by each time. See how I got that? Would you agree that if I take 3 and times it by 2/3, 2/3 of 3 is 2? So the way you can get the next term is called the common ratio. And it goes like this. This divided by this, which I just did down here, came up with 2/3. This divided by that, guess what you get? 2/3. To get out, it's dividing, and it's in a particular order. You can't just divide it any way you want. You take a term and divide it by the term in front of it. That's called the common ratio. A ratio is where you divide something, right? So common ratio here is 2/3. If I took this divided by 1, well, anything divided by 1 is itself. So it's 1/10. 1/10 is the common ratio. This is harder, but if I took 1/100th and divided it by 1/10, 1/100th divided by 1/10 is like timesing by 10 over 1, and then zeros cancel and it turns into 1/10 again. Cool. Right. So to find the common ratio for a geometric, you use this one. So I'm going to give you a geometric. It starts with 5, and I times by 2 and I get 10, and I times by 2 and I get 20. Notice at the beginning you can't tell if you're adding 5 each time or if you were timesing it by 2. But once you see this one, you can tell, oh, it wasn't add 5, right? So then I can go, this divided by this should equal that divided by that. Yep, it's a common ratio of 2. So your R is 2. Your A is your start value. You should be able to tell me what the 10th term. Is it always the 10th term? No, I just trying to be consistent. Find me the 10th term in this sequence. A sub 10 is 5 is what we started with, times R, the common ratio. What's the common ratio? Say it if you know it. 2. To the n minus 1, oh, n is the 10th term, so 10 minus 1 is 9. I got to go 2 to the 9th? Holy crap. And then I have to times that by 5. This is called exponentials. We did them before. This is your start value. This is a number to a power, and the power used to have a variable in it, so that's an exponential. Well, 2 to the 9th, 2 times 2 is 4 times 2 is 8, 16, 32, 64, 128, 256, 512. Anybody else get 512? All right. 512 times 5 then. 5 times 5 is 25. I have a couple zeros, but then I got to go 5 times 12. That's not that bad. That's 60. So 25. I think it's 2560. Can anybody verify that? All right, cool. There we go. That's our 10th term. It uses this formula. So is all you need the formula? Well, kind of. You got to know whether things are geometric or arithmetic. No formula can tell you that. You have to use your brain. Number 2, you have to know what A and R and all those things are. So A is always the starting one. R is the rate, the common ratio. And N is which term you want. All right. Now, here is a combination of them giving you the formula in weird ways. You have to figure out from this that, oh, actually it's just an arithmetic one. And once you know it's arithmetic, you can use that formula we just taught you. And then you can figure out what the 5th term is or whatever. All right. So if I needed to figure out if it's arithmetic, geometric, I would figure out the first few terms. And we already did this one. So let's do, we do a fair amount of these. The way that looks. I'd like you to go do this one. And I would like you to actually find out for me what the 8th term is of this sequence. First, I know there's more than one way you can do it. You can do it the caveman way where you can find all 8 terms and then just write down the 8th one. Okay, I don't want you to do that. I want you to use the formula because when we do this, we're not going to find the 8th term. We're going to find like the 248th term. Okay, so figure out the first few terms of it, then use the formula to figure out the 8th term. I'm going to pause for a sec while you try that. So if the first few terms are 1, 3, and 5, ... How do I figure out, is this arithmetic or geometric? Arithmetic. And then I use that little formula, and that's a sub n is equal to a, and then remember the rest of it?
Yeah. Minus, or a plus, and then I add 8 minus 1. It's
Yep.
the term minus
Yep.
1.
Times the difference. Okay, now let's put the numbers in there like I think that you wanted to do. So it was the a sub 8 would have been
1 plus 8 minus 1 times 2.
good. 7 times 2 is 14. We're going to add 2 7 times. So that's 14 plus the one we started with would be 15. So the 8th term should be 15. Raise your hand if you had that one right. Cool. You get how this is really complicated looking, and you have to use a formula, but it's really just figuring out the 8th number that comes in this sequence. It's not that bad. I don't feel like it is. All right, and that's our day 1, so those are usually more complicated feeling. All right, how do you tell if this is arithmetic or geometric? Find the first couple terms. Would you please find the first 3 terms? Pausing. Okay, so first 3 terms. Taddy, what'd you get for the first term? When you stuck in k was 0, I hope that's what you stuck in.
I stuck in 1.
Oh, okay. We really should put in 0 first, but tell me what 1 was when you stuck in 1.
You do 1, you'll get negative 1/3. Right?
Okay, can anybody verify negative 1/3 was one of your terms? Okay, good. Henry, did you put in 0 first?
I did not.
Okay, see how it says k is greater than or equal to 0, so everybody got to start with whatever it says. So I'm going to stick in 0, and I put anything to the 0 power, I get 1. So then this is 0, because 2 times 0 is 0, plus 1. 1 over 1 is 1. Okay, so 1, and then negative 1/3, and then I feel like I'm just going to keep multiplying by 1/3, but I don't know. We'll find out. Jasmine, what did you get when you stuck in k was 2? 1/5. Anybody verify 1/5? A bunch of people. All right. So then it looks like, oh, I'm going to end up getting like progressive odd numbers in the basement. So you could think of this as 1 over 1, right? 1 over 3, 1 over 5, and then it's going to be 1 over 7. Are we adding the same thing each time? No. Are we multiplying by the same thing each time? No. Then neither of those formulas would apply. You know, those arithmetic and geometric formulas, you can't use them. Is there still a way to do it? Sure, there is. But we're not going to make you memorize a formula for this. All right. So let's move on. So here's our official 2 formulas that we just used. It's just listing them. That's how you do the arithmetic kind. That's how you do the geometric kind. Okay, moving on. This is where we get to the homework. So I just want to get you started on the first one so you see that these are just like how do you get the first few terms? They want the first 4 terms. Okay, so if I stuck in n equals 0, always start with what they say to start with. I'd put in 2 to the 0 minus 1. 2 to the 0 power is 1. 1 minus 1 is 0. And then I stick in the next progressively larger integer. So what's bigger than 0? 1. So I put in a 1. And I go 2 times 1 is 2 minus 1, which is 1, comma. Well, it looks like I'm just going to add 1 each time. Well, let me find out. So I'm going to go put in 2. And I get 2 times 2 is 4 minus 1 is 3. Oh, 0, 1, 3. Double check I didn't do something wrong. 1, 2, 2 to the second is 4, 4 minus 1 is okay. So then the next term is, I put in a 3. And that's 2 to the third is 8. 8 minus 1 is 7. Did you guys get 0, 1, 3, 7? Okay. Looks like I'm not adding the same thing each time. Also, I'm not multiplying by the same each time. So this is not arithmetic or geometric. So what they ask you to call them is neither. We don't have a fancy name. It's just not arithmetic. It's not geometric. So it's neither one. All right. Try to get the next few on this one. And then let's move on to this page and just see the difference here. You just get progressively stranger looking. They're saying here that you're starting with 117. And to get the next term, remember, always look here and go, oh, they want me to start with putting in a 1 for my n. And it appears that you take 1 over the term before you. Again, weirder and weirder ways to describe sequences. Can you figure them out? Then here is where you get into like a typical test question, things that you'd have to be able to answer. So I would definitely try to do a few off of this page. You know, they have circled ones. Well, they circled almost all of them, but I mean, they maybe cut it down to half. And then maybe you don't have to even do all of those. Go through and find several of the circled ones and do them because that's what gets you better at this. All right. And if some of you just got test scores back that you don't like, one of the reasons is that you probably didn't do enough practice. It's just the way it goes. It's sad, but it's true. All right. And that's also just having a bad day. That can happen too. If this was a bad day for you, then do corrections. You can take a retake on the vectors test that I just handed back. All right. So I strongly recommend doing some homework. That's all I got for the video for today.